Hi, welcome to the lecture 2. So here we will learn about the lemma 2.113. So if you see here for clarity, it states that if P is a prime number and P is congruent to 1 mod 4, then there exist a positive integers a comma b such that a square plus b square equals to P. Okay, so they are saying that if P is a prime number and P is congruent to 1 mod 4, this condition comes from the previous, it means this is like similar thing we have discussed in the previous theorem. Okay, if it is so, then there exist two positive integers. What? This is important. Two positive integers such a and b such that a square plus b square equals to p. Okay, nice. Okay, so let's discuss about this proof. So proof is about using the previous theorem. Okay, what does previous theorem states? This is the previous theorem. Previous theorem states that let p is the prime number. Okay, then x square is congruent to minus 1 mod p as a solutions if and only if p is equals to 2 or p congruent to 1 mod 4. Okay, here I want to introduce one new term, that is odd prime. So odd prime means, generally prime means what? What are the prime numbers? Tell me.
Which are divisible by 1 and then
What are they?
2, 3,
5,
5,
7 and
7,
so on. So generally prime numbers are odd only except 2. So all the prime numbers, these prime numbers are known as odd primes. What?
Odd primes.
Odd primes. Odd primes is nothing but they are saying that exclude 2. Okay, so some people will call like that. So this is the p equals to 2 and odd prime congruent to 1 mod 4. Okay, this is okay. What you understand this theorem? We are saying that x is congruent to minus 1 mod p. This has solutions when means this condition p is equals to 1 mod, p is congruent to 1 mod 4. What do you mean by this? Tell me. P is congruent. What are the possible values of p? P can be 1 or what? 1 plus 1 into 4 5 or 1 plus
2 into 4
2 into 4 how much?
9.
Next
13.
13 and so on. Similarly, like 1 plus 0 into 4 how much? 1 plus minus 1 into 4 how much? Minus 3 means negative also. Okay, like that. Okay. Understand? So here proof says that first step in the proof is that x square is this has a solution if and only if this one. Okay, now let's say we define one function. Okay, one function. This function is having inputs u comma v. Okay, what is the value of function? Just like quadratic equation. What is quadratic? F of x equals to x square plus bx plus c. Just like here, what is x? X is an input. This is known as y. Y is output. What is the, just like if I ask f of x equals to 2x square plus 3, f of 1 how much? What is the output of f of 1? 5. Okay, output of 2?
7.
11. Okay,
2 square 4. Okay, 11. Yeah.
Okay, like that. Okay, so just like that, here only one output. What? One input. One input, one output. Here we are saying that there will be two inputs, u and v. So there will be only one output. So here important thing is, what is x? X is nothing but this x. Okay. Happy? So okay, let's define k equals to, this is called as, some people call as GIF. GIF is not about graphical interface format. The GIF is greatest integer function. Okay.
Okay.
Huh?
Okay.
So greatest integer function are known as floor function. Floor function means, see, just assume that this is floor, this is air, this is seal. Floor function means that if all the values will drop down to floor.
Okay.
All seal function means all values will be stepped up to seal. Means suppose I am having 4.5. What is floor of 4.5?
4.
4. Seal of 4.5 how much?
5.
5. Like that, simple things. Okay. This floor function in our JE, it is known as box. How you study this? Box of root p. Okay, box of root p. Okay. Now tell me, what is p? What is p?
This prime.
P is a prime number. Happy? Okay, nice. So, can prime number be a perfect square?
Yeah, sometimes. No, I don't think so. No, it can't be a perfect square.
Perfect square. See, let's say k is some number, k square. K square is a perfect square. Okay?
No, it can't be.
What are the divisors? 1k and k square are the divisors. But for a prime number, what? 1 in itself.
Yes.
P square cannot be a divisor.
Yes.
That's why prime number is not a.
Perfect square is not a prime.
Okay. Prime number is not a perfect square.
Okay.
Now tell me, what is the value of box of 4.5?
4.
4. Box of 4 how much?
4.
4 means box of x equals to x when
it is a perfect square.
when x is a
Even
normal
number.
integer.
Normal integer, yeah.
Not even number. X is an integer. Okay, this is the point you have to remember. So tell me whether root p can be, since p is not a perfect square, can root p be a integer?
Yeah, maybe there are chances.
I'm saying p is not a perfect square.
Okay, no, there are no chances.
If p is not for, let's say root 48.
No chances.
If root 48, happy, it will be 7. But root 48 means something points, 6 points, something blah blah blah. So I'm saying, what I'm saying, finally concluding means that root p cannot be equals to k. The p, this root p inside value cannot be equals to k. And it is less than k plus 1. Okay. I told no concept this. This is called floor. This is called seal. So if this value is 5, what will be the next value? 6. So my value is between here. So my value, box of any values between, what will happen? It will downfall to where? K. Okay.
Yes.
So now observe this. Root p is always less than 6 and always less than 5.
Okay.
So that's why I have written k less than root p less than k plus 1.
Okay.
See, one more thing, there is one property in small mathematics. If you are kid, in the kid times, it is said that for boxes, let's say I equals to boxes, then we have one inequality. What is that inequality? Okay, this is the inequality.
Okay.
This is, anyone bacha will know this one. Okay, who done basics very well. So now what I am saying, since x is not a what here, not an integer, I am saying I am removing this inequality. Okay. Now, okay, this is smaller sum. So the come to next. So let define u and v such that those values will be only 0 to k. Okay, so okay, chalo. So let take u and v such that the values will be in 0 to k. Okay, so now I am asking, how many number of pairs will be possible? U and v. See, you can take possibility of how many values? U is an integer, u and v are integers. Okay, now tell me how many possible values for this? u can be 0 or 1 or 2 or 3 and so on
k minus
so
something. Yeah.
so what
Okay,
are
up to k. Yeah.
k plus 1.
K plus 1.
This is k plus 1.
Okay.
So then according to the fundamental principle of counting, what will you will do you want both at a time. So you will do multiplication. So number of pairs will be k plus 1 whole square. Okay, next. Now for this equation 1, I am applying mod on both sides. So see I am going from everything basic, so the video will be lag, but you keep in 4x 3x and try to listen everything. Okay, so applying mod 1 to equation 1. Now this will become 2. Like I am saying how 1 become 2. Okay, applying mod on both sides. This is u comma v equals to, tell me, u plus vx. Now applying mod p on both sides. So what will it become? U comma v mod p equals to u plus vx mod p. We already know that previously in yesterday class I told that a percent m equals to b percent m. This is another way of notation. How? Tell me. A is congruent to b mod m. So that is what I am written. Okay, p of u comma v is congruent to u plus vx into mod v. This is the definition itself. Okay, don't think so much. That is how they define mathematicians. Okay, now you got equation 2. See, from this equation we came to know that k is less than root p less than k plus 1. So root p less than k plus 1. So p less than k plus 1 whole square. So k plus 1 whole square is greater than p. So for the values u less than or equals to v less than or equals to v, total number of pairs possible, how many? Tell me. K plus 1 whole square. So now this what I am saying, that means here u and v you will substitute na. U and v different inputs you will substitute. So those many pairs are greater than p. That means that if I apply some two different inputs, then two different inputs will be collide to one. Okay, you got it. See, you tell me what are the possible values of this one. I told anything percent m means mod m. What are the possible values? Tell me. 0 to, yesterday I told in previous class, I mean 0 m minus 1. You got it. Anything mod m can be always values will be, tell me, 0 to
m minus 1
pakka. So here the values will be what? Possible values 0 to
p minus
1 means how many values possible? Unique values. Unique and distinct values, how many?
p minus 1.
0, 1, 2, 3 and so on, p minus 1. So how many total? How many? Till here how many? Tell me.
P minus 1.
This is 1. So total how many?
P.
This is simple. You are not able to tell how. So total values are p. But the inputs which we are giving, the number of pairs are more than this p. That means then we can say there exists at least two pairs. At least two pairs such that their values are equal, means those values are colliding. Okay, so the such pairs will be u1 v1, u2 v2. So what now? Tell me, for this function it is colliding, means what? How will you write? u1 plus v into x1 mod p equals to u2 plus v into x2 mod p. This can be written as how? u1 plus v into x1 congruent.
How did you write this one? Explain last step.
I'm saying that how many number of unique values possible from this? Total number, tell me. 0 to p minus 1. So I'm saying that from this the possible values will be p values. I'm saying the number of pairs which can be given to this function. How many, tell me? K plus 1 whole square, which are greater than p. So now I want to know that if I give k plus 1 whole square, which are
one more doubt is like you k plus 1 into k plus 1 whole square,
yes,
right? Like that it came. Okay. Then
okay. Yes. So I want to know how many unique values will be possible to obtain. It will be pakka p only.
Okay, sure.
Yeah. But now I am giving how many input? K plus 1 whole square, which is greater than p. Can I expect for all the inputs, means u1 v1, u2 v2 and so on, un vn, for all inputs, outputs will be also different?
Maybe.
Let's say I will tell about like this. This is 5. Let's say this is 100 and this is 150. So I am having 100 inputs.
Okay.
I am having here 50 outputs. My question is that can I expect that, let's say if I match like this for everyone. So will I able to get successfully?
Not all, but some of them will get matched.
Not all, some of them will be get matched. Okay, that's the point. See, I will tell in another way for you. I'm having here 10. I'm having here 5. I'm saying that for every point there will be one line. What? For every point
there will be one line. Yes.
One line means one output. One output compulsory is there.
Okay.
For every line. And these are the unique values. Means every dot in this one will have a compulsory line. Okay. Okay. Now tell me. Like now you are trying to fill it up, means matching. So this here this condition is happy, means for every point there is line happy. Now here another condition, what is, tell me? For every point one output, one line should be there. But here these are not there. But to make our what you have to map against to some random.
Okay, okay, yeah. By this we can do this.
Okay. This means that there will be like 2 inputs, at least 2 inputs,
yes.
such that output will be same.
Okay, yeah.
Means these are different inputs, but what you are getting same output or not?
Yes.
That's what I am saying. So when number of pairs, when the inputs are very greater than the unique values, then one mapping is not possible.
Yes.
Okay, this is what mainly I want to tell. Okay, so come up very fast. Okay, so there exists at least 2 pairs such that u1 v1 which satisfy this condition. So what will become? u1 plus x into v1 is congruent to u2 plus x into v2 mod p. Now you take it as left side. So okay, you understand? From this, these 2 values will be equal and you get this one. Now shift to left side. What will happen? u1 minus u2 is congruent to x into v2 minus v1 into mod p. So what will happen? u1 minus u2 congruent, I mean this, I think u plus vx, nice, minus x into v1 minus v2 into mod p. Okay, this is what you will arrive. Samjha?
Okay.
That's it. So now take it as something a like this, and take it as some b. Now what will happen? A is equal to minus xb mod p. Okay, I told at the beginning what are the possible values of u and v.
X plus 1
0 to k range man.
range to.
So what is the possible values of u1 minus u2 in general? So maximum can be when it can become k and it can be 0. So k minimum can be when it is minus k and it becomes 0 minus k. Samjha? Similarly we can comment about v1 minus v2 equals to minus k2 plus k. Okay, you understand this much? Next, from this step take this one, do this 1 into 1 multiplication. So what will happen? Tell me. 1 into 1 1 into 1, take again this only. Now tell me, we can there is one property, we can multiply each other. So what will happen?
A square equals to
a square not equals, this is called congruence symbol.
Congruence.
X square b square
mod p square whole
not
square.
p square. You understand? This is the property. Okay, just only these terms will be as it is copy. Okay, this is the theorem, fundamental. Theorem means I mean in the definition of theorem it will be there. And one more thing we know that from the equation x square is congruent to minus 1 mod p. So substitute here.
Yes.
See, now take this one, multiply b square on both sides. What will happen? Tell me. Multiply b square on both sides. What will happen?
A square
for this one.
Bx square
is congruent to minus b square into mod p. Now see, we know one property. What is that property? Tell me. The property is a is congruent to b mod c. In previous class I told na. B mod p, b mod k or f. F. So from this what will you can conclude? Tell me. A is congruent to c mod
f.
fo. Okay. Similarly, can I write this?
Yes, exactly.
Mod p. So a square plus b square is congruent to b mod 0 mod p. So from this what can we write? Tell me.
A square
p divides a square plus b square. So a square plus b square equals to p into some
k.
Let's say not k, some, tell me some other constant. Some f. Where f is a
prime.
F is an integer, man.
Integer, yes.
Basic funda.
Okay, yes. Yes, f is an integer, exactly.
F where f is a integer. Okay. So now what we want to prove it? Tell me. A square is equals to b square is equals to pf. Means I want to prove that f must be exactly equal to p. But not p into some number.
Yes.
Exactly equals to p. Now how will you prove it?
A square, if a square plus b square.
No, don't tell anything. Just understand what I tell. So RTP. What is RTP? Required to prove. Required to prove that is a square plus b square equals to exactly p. So now what will you use? Concept means here. See. Here u1 minus u2 can be termed as a. v1 minus v2 can be taken as b. Okay. Now minus k less than or equals to a comma b less than or equals to k. Now tell me the range of a square plus b square. What will the a square value? A square can be taken as 0 to k. Similarly, b square can be taken as k square. Okay. So next step will be, since previously we know that k is less than root p less than k plus 1. So from this what can you conclude? Tell me. I know previously this one.
Yeah.
So from this what I can write? Whole
K
square.
square k plus 1 whole square.
Take only this much. So k square is less than p. See, 1 less than 2, 2 less than 5.
So of course.
Can I write 1 less than 5?
5, of course, yes.
Of course, no. So because of this, now I can write happily that a square is less than p, b square is less than p.
So a square less than p.
A square plus b square is equals to
less than 2p. Okay.
less than 2p. Not equal by less than.
Okay, yeah.
This is the basic funda. Now tell me. PF. Okay. Now I am considering that since they have given that only positive integers. So since consider only as a positive integers. So a square plus b square is less than 2p. But we know that PF is less than. What is the a square plus b square? Exact value.
PF.
What is f? F belongs to some integer. Okay, so PP cancel, prime number.
Okay, f less than 2.
F less than 2. So since it belongs to Z. So one more thing, one beauty thing. What you have to observe, one beauty. Beauty is that a square plus b square. Can it be a negative?
No, it can't be.
It can't be. So can I comment that PF is greater than or equals to 0
yes,
always?
super.
Pakka na?
Sure.
Sure na?
Sure.
Nice. So from this, since P is a what? Bacha prime number. So can I divide both sides? So can I conclude f greater than or equals to 0?
Yes.
Okay. So can I write like this? 0 less than. Okay.
It lies between 0 or 2.
This is Z. So now tell me what is the possible values of f?
0, 1. That's it.
That's it. Okay. As per our theorem, what? A and B should be what? Positive integers.
Yes.
Positive means?
Greater than 1,
0. So we ignore this.
F value is 1.
F
so
value is 1.
plus
A square plus B square equals to P. So this is what? Desired result.
Yes.
Okay. See why they explicitly mentioned A and B. I mean explicitly mentioned positive integer. Why so means now you can realize here.
Okay.
Because suppose if you don't mention positive integer, it can be a 0.
Yes.
Then there will be a two values.
Two values.
Two values. Then we cannot tell anything now.
Exactly.
So this is the important thing. So that's it. So this is our desired result. So let's discuss briefly like what they have written. So same thing, like see the author also like beautifully written here, same whatever like I have to. So what previously I have discussed now, like if I am having k plus 1 outputs, means 100 outputs and 50 are there, so then there will be like a same matching. So we assume that there exist two numbers which will be same. This is known as pigeonhole principle. What? If you want to know, you can search it. Pigeonhole principle. Okay. Pigeonhole principle says that if we are having, let's say, four nets. Nets means in a net a bird will be like jailed. So I am having one net. I am having I am having 4 nets. I am having 5 birds. So I want to keep all 5 birds in the 4 nets. So is it possible that all 5 birds can be placed in 4 nets or not? Tell me.
No.
Let's say N1, N2, N3, N4. Bird 1, bird 2, bird 3, bird 4, bird 5. If I keep in 1 mapping,
one will remain.
One will be retained. This is not that true. So we need to forcefully keep in some another one.
Yeah.
This is called pigeonhole principle.
Okay.
This just bacha common sense only they have written like a fancy name, Pigeonhole principle. Okay, that's it. Finally, like we have arrived it and concluded. So that's it. Thank you.